ever just looked up at a plane cruising like 30,000 feet in the air and thought, how? I mean, really, how does something that massive just hang out up there? We see them all the time, but when you stop and think about it, it's kind of mind-blowing. Well, today, we're going to peel back the metal and get right into the heart of one of the greatest inventions ever, the modern jet engine. Just to put it in perspective for you, a big plane, like a 747, it can weigh more than 80 elephants. Yeah, you heard that right, 80. And yet, there it is, soaring through the sky at almost 900 kilometers an hour, all thanks to those incredible things hanging off the wings. So that's the big question, isn't it? How on earth does what is essentially a spinning metal tube, a tube with a controlled fire inside it, manage to lift something the size of a small building off the ground and fly it across oceans? That is exactly what we're going to figure out. And I promise, by the end of this, it's all going to make perfect sense. To understand this incredibly complex machine, we have to start with something super simple, something you've definitely played with before. We're going to start with a balloon. Think about it. You blow up a balloon, you pinch the end, and then you let it go. What happens? Air blasts out the back, right? That's the action. And because of that, the balloon zips forward all over the room. That's the reaction. That's it. That's Newton's third law in its purest form. Every action has an equal and opposite reaction. You push air one way, something else has to go the other way. And that forward push, well, it's got a name. It's called thrust. A jet engine is basically just that balloon, but on an epic, massive scale. Instead of just letting out trapped air, it's a beast that's constantly sucking in huge amounts of air, setting it on fire, and then blasting it out the back with unbelievable power. And to do that, it uses a brilliant 5-step process. All right, so let's meet the key players inside a modern jet engine. The easiest way to think about this is like meeting the characters in a story. Each one has a really specific, really important job to do. So first up, you've got the fan at the front. Think of it as a giant, powerful vacuum cleaner. Right behind that is the compressor, which is basically a big squeezer. Then things get really hot in the combustion chamber. That's the furnace. After the fire, we have the turbine, which works kind of like a high-tech pinwheel. And finally, everything makes its grand exit through the exhaust nozzle. Okay, now for the fun part. Let's see how this whole team works together. I want you to imagine you are a tiny little molecule of air, just minding your own business, floating around. Because you're about to go on the ride of your life, step by step, right through the heart of this engine. Whoosh! In a split second, you're sucked in by that giant fan at the front. And this thing is huge. On a big plane, it can be 3 meters across. It's spinning so fast, it pulls in literally thousands of liters of air every single second. But here's the crazy part. Most of that air doesn't even go into the engine's core. It actually flows around it. This is called bypass air, and it's what makes the engine so much quieter and more efficient. And that's exactly why we call it a turbofan engine. Okay, so you're one of the unlucky molecules that gets sent into the core. You're immediately pushed into the compressor, and this is where things get, well, tight. It's a whole series of spinning blades that get smaller and smaller, squeezing you and all the other air molecules together. By the time you get to the end, you've been squished to about 40 times normal air pressure. You know when you use a bicycle pump and it gets hot? That's exactly what's happening here, but on a massive scale. The air is now super dense and super hot. And now you're blasted into the combustion chamber. This is the heart of the beast. A fine mist of jet fuel is constantly sprayed into the super compressed hot air. And then ignition. It erupts into this continuous, controlled, absolutely ferocious explosion. Just how hot are we talking? Over 2,000 degrees Celsius. Let that sink in for a second. That's literally hotter than lava. It's hot enough to melt pretty much any metal you can think of. And this incredible release of energy creates a massive rush of gas that has to go somewhere. And there's only one way out: backwards. On its way, this scorching hot gas slams into a set of blades called the turbine. It's kind of like holding a pinwheel in front of a really powerful hairdryer, except the air is a 2,000-degree inferno moving at hundreds of meters a second. It spins the turbine at mind-boggling speeds. And right here, this is where the design becomes absolutely genius. That spinning turbine, it's connected by a long shaft all the way back to the front of the engine. It's the turbine's job to power the compressor that's squeezing the air and the giant fan that's pulling it all in. So the engine is powering itself.
It's this beautiful, self-sustaining loop. The fan pulls air in, the compressor squeezes it, the fuel burns it, which spins the turbine, which then powers the whole thing all over again. It's just brilliant.
So finally, what's left of those superheated high-speed gases shoots out the exhaust nozzle at the back. This is the moment we've been waiting for. The gases blast out at nearly 1,000 kilometers per hour. And that is the powerful action from our balloon experiment, creating the equal and opposite reaction that pushes this 80-elephant machine through the sky. Okay, so now you get the process. But let's go back to one little detail that seems completely impossible, a piece of engineering that honestly shouldn't even work. It's about those turbine blades we just mentioned.
Just think about that for a second. The metal blades that are essential for the whole thing to work are spinning around in a gas that is hotter than the temperature needed to melt that very metal. So how? How do they not just turn into liquid goo?
Well, the solution is just breathtakingly clever. The engineers built these microscopic hollow channels all throughout the inside of each blade. Then, the engine takes some of the cooler air from the compressor stage and pumps it through these tiny holes. This creates a thin, invisible layer of air that wraps around the blade like a shield, protecting it from that insane heat. It's precision engineering on a level that is just hard to comprehend. All right, we have been on quite the journey inside that engine. So let's lock it in. Let's do a super fast recap of the whole story. We can boil it all down to just 5 simple words: pull, squeeze, burn, spin, and blast. First, the fan pulls the air in. Then the compressor squeezes it. Fuel is added and it burns. That hot gas spins the turbine, which powers the front. And finally, the exhaust blasts out the back, creating thrust. Pull, squeeze, burn, spin, blast. That's it. That's the secret sauce of a jet engine. So the next time you're on a plane and you're looking out the window at that engine pod, take a second. Imagine what's happening in there. A hurricane of air is being pulled in, squeezed, burned, a temperature is hotter than a volcano, and blasted out the back, all just to keep you peacefully floating 6 miles above the ground. It's not magic, it's physics, and it's some of the most brilliant engineering on the planet. Pretty amazing for just a metal tube on a wing, right? So what should we break down next? Let us know.